This lesson is on variables and expressions. A numerical expression is a mathematical phrase with only numbers and operation symbols like addition, subtraction, multiplication, and division. An example of a numerical expression would be 8 plus 5 minus 2. Now, an algebraic expression is a mathematical expression with one or more variables. And a variable is a letter that stands for a number. For example, n plus 4, where n is the variable. 6 times d, or 6d, that means 6 times d. 8 times b minus 2, or 9 times x divided by 3. Those are algebraic expressions containing variables. Now, to evaluate an algebraic expression, you replace or substitute each variable with a number. Then you use the order of operations to simplify the expression or to work the problem. For example, n plus 15 is an algebraic expression, and they want us to evaluate or find the value of it when n equals 8. So I'm going to replace n with 8, and I do 8 plus 15, and 8 plus 15 equals 23. Here's another one, 18 divided by d for d equals 3. That means I substitute or replace d with 3, and 18 divided by 3 is 6. Y plus y plus y when y equals 4. So I substitute or replace y, the variable, with the number 4, and I have 4 plus 4 plus 4, which is 12. Here are some more. 3 times x plus 12 when x is 7. So this time I do 3 times 7, I substitute 7 in for x, plus 12. Now I have to use the order of operations. I'm going to multiply first. 3 times 7 is 21, and 21 plus 12 is 32. 5 times q divided by 2 when q equals 8. So I'm going to do 5 times 8 and then divide by 2. 5 times 8 is 40. 40 divided by 2 is 20. 25 minus 4s when s equals 6. So I do 25 minus 4 times 6. Now I'm going to do the multiplication before I subtract because of the order of operations tells me that multiplication comes before subtraction. So I have 25 minus, and 4 times 6 is 24. 25 minus 24 is 1. Now, let's take a real-life example of why we would use this. Student council doesn't know how many people will attend the dance, but they do know that each dance ticket will cost $5. So evaluate the expression 5p, or 5 times p, where p represents the number of people who bought tickets, and 5 stands for the amount of each ticket cost. Each ticket's $5. So if we have 50 people buy tickets for the dance, I'm going to do 5 times 50, which is, I can do 5 times 50 pretty easily because 5 times 5 is 25, so 5 times 50 is 250. If there are 100 people that purchase tickets for the dance, I do 5 times 100, which is 500. If 200 people purchase tickets for the dance, I do 200 times 5, or 5 times 200. 5 times 2 is 10, so 5 times 200 is 1,000. And then let's say 216 people buy tickets for the dance. I'm going to do 216 times 5. Each dance ticket is $5. So I'm going to work that problem, and I get $1,080. Now, sometimes you'll be asked to write an algebraic expression to describe the relationship that you see in each table. For instance, I need to know what's happening to x to get these numbers over here. So this is kind of like your input, and this is your output. If I put 10 in and I get 7 out, what am I doing to 10? And it has to be the same thing that I'm doing to 15 and that I'm doing to 17. Well, if you'll notice that this number is 3 units smaller than this one, This is 3 smaller than this one, and so is this. So I'm taking x, whatever the value of x is, and I'm subtracting 3. So the algebraic expression that represents this table is x minus 3. In this case, my input is 24, and I get 6 out. My input is 16, and I get 4 out. My input is 12, and I get 3 out. Now, I could be subtracting. Let's see, 24 minus 18 equals 6, but is 16 minus 18 4? No, so it's not subtraction. What could I be doing to make these numbers smaller? What if I'm dividing? 24 divided by what equals 6? 24 divided by 4 equals 6. Is 16 divided by 4 4? Yes. Is 12 divided by 4 3? Yes. So the algebraic expression that's represented here is n divided by 4. Sometimes you'll see it written as n over 4. That means n divided by 4 as well. Whatever you do to n, you're dividing it by 4, whatever n is. In this case, this time my input is, I'm calling it y. It's 2 going in, it's 3 coming out. It's 3.5 or 3 5/10 going in, it's 4 5/10 coming out. It's 6 going in, it's 7 coming out. What's happening each time? What is happening to y? Well, I'm taking the value of y and I'm adding 1. So the expression to represent this table is y plus 1. And finally, I have one more. This is s this time. When s is a 1, it comes out as an 8. It goes into a function machine and it comes out as an 8. When it's 2, it comes out as 16. And when it's 3, it comes out as 24. Well, what's the same consistent thing happening every time? Well, I'm taking whatever the s value is and I'm multiplying by 8. So the way that I would write this expression is 8s, which means 8 times s. And on that note, the reason we could write it as s times 8 like this, but whenever we don't use the multiplication symbol, and we don't really do that very much anymore when we get to these algebraic concepts, we don't put the variable in front, s8, because that looks like, I don't know, bingo or something. We write it as 8s, where the constant or the number comes before the variable. It means the same thing, because remember, multiplication is the same, frontwards or backwards, it's commutative. So that is a little bit about algebraic expressions.